All right, question show time. Your questions, my answers. As always, wherever you are on my channel, if some question pops into your brain, just type it in on any video. I see them all. I'll gather them up and I'll answer them here. Once again, we got a special guest answerer, so stick around to the end. All right, let's get started. Disinclined Tostate. Hey Fraser, love the channel. Will the James Webb Telescope be able to see evidence of artificial satellites around exoplanets, should any exist? Would there be a certain size or composition requirement for JWST to spot them? James Webb isn't going to be exactly the right tool for this job. So the way that like megastructure, some kind of artificial satellite or whatever around some planet is going to be discovered is going to come from the way these objects block the light that's coming from their star. And the kind of telescope that's going to be good for that kind of thing is something like Kepler, although Kepler is about to die. So it's going to be what's coming next, which is called TESS, the Transiting Exoplanets Survey Satellite. It's going to be like a super version of Kepler, and it's going to really comprehensively map out all of the transiting planets that are relatively close to us here on Earth. But you need to have these things to line up perfectly between there's Earth, you need the planet, or in this case the megastructure, and the star, and they all need to line up fairly perfectly for this to happen. Once TESS turns up some of these artificial satellites, then something like the James Webb Telescope could do some follow-up observations and maybe try to get some more details. Now, astronomers have calculated the kinds of light signatures, so how that light would change, that transit, if this artificial structure moved in front of it. And they've sort of mapped out different kinds of signals that they would expect to see in the brightness. Because, you know, if you've got a planet, you've got this rounded shape, it's going to have this very, very smooth change in brightness as it moves in front of the star. While, say, something that was like triangular shaped would have a very different light signal. So once TESS gets operating, starts to map out these stars and map out these planets, astronomers will totally be looking for anything that's out of the ordinary that could indicate there's some kind of artificial structure. And one of the ideas they've thought of is that maybe this is the easy way that aliens are going to try to tell us that they're there. They build something that has to be artificial so that when we get powerful enough to be able to detect them, we realize that the aliens are there. And they do it by making, say, triangle-shaped satellites around their star. It's a great idea. Matt Gibson. Fraser, if you could pick any FTL travel method from any show or movie and have it be a reality, give it to humanity, which one would you pick? Some examples include Elite Dangerous, Star Wars, Star Trek, Battlestar Galactica, Stargate, etc. I would totally choose Stargate, 100%. I mean, I love the idea of space travel being some version of naval travel. I mean, that's really what Star Trek and Star Wars are, is they're naval battles, but they're in space. But I love that idea of Stargate, that you've got this physical wormhole and you can just walk up to it and walk through it and you appear on some other location far away. And I actually really love the Stargate, the way they handled just how those Stargates worked and how they had developed technology that would fit the way the ships would go through these Stargates. It was a really clever idea. So yeah, if I had to choose one FTL method, I would totally pick Stargate. Wormholes for the win. Chirodal. Hey Fraser, I have a question about the birth of solar systems. If there's less mass in a gas cloud which collapses into a star system, it'll form a red or brown dwarf. Is it possible that a gas cloud with very little mass could collapse and form a star system where the central body didn't light up? Will these no star systems send out any radiation or light that we can measure? Thanks in advance. There's no reason to expect why you couldn't get a smaller star-forming nebula, and all it has the mass to be able to do is form something that's even less massive than a brown dwarf, right? So in the biggest star-forming nebula, you're going to get multiple super heavy giant stars. And then maybe in a smaller one, you're going to get stars like the Earth. And maybe in a smaller gas cloud, you're going to get red dwarf stars, and then maybe you're going to get brown dwarf stars. And then you can imagine for the smallest enough one, you're going to get like some kind of Jupiter-sized world. So absolutely, there's no reason to think why it wouldn't happen. And in fact, astronomers have calculated there could be billions of these rogue planets all across the galaxy floating free. They weren't in any way formed with any larger star system. They just formed. And as you said, the challenge is going to be able to see them, right? There are red dwarfs in the sky. The vast majority of stars out there are red dwarfs, but you pretty much can't see any of them with the unaided eye. You can't even see, say, Proxima Centauri without a telescope. Brown dwarfs are even harder. And so you can imagine something that's just a Jupiter-sized world out there is going to be really tough to detect. We're probably only going to be able to find them using techniques like, say, gravitational microlensing, where one of these rogue planets passes in front of some star and we see a change in brightness of the star, and then we know that a planet passed in front. But it's going to be hard to be able to find these things. Ed Chartrand. I'm fascinated by the images depicted in films like Star Wars, where characters look up into space on far-off planets where there are multiple moons practically filling the sky, or one moon that is massively larger than what our moon appears in reality here on Earth. Are these types of visuals actually possible on planets from a physics perspective? Can a moon be so close to a planet that it takes up that much of the sky and still have a stable orbit? Not exactly. I know what you're talking about. You're on some exotic alien world and you look up and there's this gigantic moon hanging there in the sky. And the reality is that if that's the case, then that moon is really close. And if the moon is really close, then it's about to enter the Roche limit, be torn up and splat into the planet itself. So, you know, when you think about the moon, you can hold your arm out and with your pinky fingernail will just cover the moon. Actually, same thing with the sun. And so if the moon was closer, bigger, the tides would be worse. It would have all kinds of unintended effects. But there is a way that you could have that kind of a system, which is that if you're on a planet and it's actually a moon orbiting like a gas giant. And so when you think about, say, Endor in the Star Wars movies, right? It was a forest moon, kind of like this, orbiting around a gas giant. And then you would have that situation where the gas giant is gigantic compared to what you're going to be seeing from, you know, from the ground. And you're going to be the one that's orbiting the planet. So that's the way you would get around that. And I'll try to put some pictures up that show some really great, people have said like, oh, what would it look like if Jupiter was as close as the moon? Or what would it look like if Saturn was as close as the moon? And we'll put those up. Michael K. I thought the ISS has some kind of micrometeorite protection and doesn't trust in pure luck. The International Space Station has sort of a mix of protection and luck. So the way it works is that in all of the various habitated modules in the International Space Station, they have this layer made of like a Kevlar material. And so it can stop most of the micrometeorites that come in from space that would normally just kind of punch through the outer shell of the space station. But when you get outside of these areas where the astronauts live and work, then they don't have any protection. You can actually see in some of the solar panels and stuff, some of the punctures that have been blasted through by chunks of micrometeorite. When the space station knows that there's a very significant chunk of debris coming their way, then they'll move the station to minimize the chances that they're going to interact with each other. But the reality is that if a big enough chunk comes through the station, even that protection, that protective layer that they have outside of their modules is going to be able to hold up against it. It's going to punch a hole through and they're going to have to deal with it. And I'm sure they're trained in case that event happens. Jim Becker. Fraser, I was looking at the photo released by NASA from the Curiosity rover, which includes Earth as the brightest point of light in the night sky. So why can we see Earth from Mars, but we can't see Mars from Earth with the same ease? We totally can. It's just all about timing. So when we're doing this video right now, we're nearing what's called Mars opposition. And this is the time when essentially Earth and Mars are lined up together in the sky, and Mars is close to its brightest point in the sky. And around July 2018, this year, Mars is going to be really bright in the night sky. You won't be able to miss it, and you'll remember this video and you'll get a chance to go out and see it. In fact, I don't know if people remember back in 2003, Mars was the closest and brightest it was going to be in like 50,000 years or something. Well, this year it's going to be almost as bright. So it's going to be a really good year to be able to see Mars, and you will totally be able to see it. So it just matters on where they are in their orbits around the sun on what you can see. Right now, I think Mars is in the morning sky, and it's not very bright, but it's going to get much brighter very quickly. Drew LS6. Could a hobby-level astronomer benefit from combining two decent smaller telescopes to make an effectively larger binocular telescope, like two 100-ish millimeter combined into an effective 200-ish unit? I ask because you can buy a pair of the smaller units for a couple of hundred, while a 200 millimeter scope is many, many times more expensive. You're trying to build an interferometer, and I admire the goal, but there's a problem. So we've talked about interferometers a couple of times before in the past, and this is where if you take two telescopes and you separate them, but you're able to kind of make the light that comes from those two telescopes show up at exactly the same time, you get the effectiveness of two telescopes. You actually get, it creates the equivalent of a telescope that is the size of the separation of those telescopes. It creates that much of its resolution, not as much of its actual sort of light collecting power. So there's very big advantage to creating this baseline. And so the idea is, could you do this on your own? Could you create two telescopes, set them side by side, and have them combine their light and get that same effect? And if you could line up the wavelengths perfectly so that those wavelengths are exactly matching up, then you could. But it's an incredibly difficult technological challenge for these optical light telescopes to do, and they have to use lasers, and they have to make sure that the interference patterns of the two telescopes is perfect. It's very hard to do. But if you went and bought two, say, 100 millimeter telescopes, and you could set them up like a big pair of binoculars. And I've seen some people who've actually done this, where they set up two telescopes, and then they have a way that they can sort of sit in this really cool chair, and the two telescopes are acting like binoculars, and it's awesome. So if you want to build even more hardware, then you totally could. But if you added those two telescopes together, you are going to get the combined light of those two telescopes, right? But you're not going to get that special interferometry where you're getting that larger baseline between them. So really, it's better to shell the money and get the bigger telescope, or build that awesome binoculars that I was talking about. But no, this is the problem with telescopes. The bigger they are, the more expensive they become. Flynn Bryant. Hey Fraser, my question is, what is the criteria for questions that you answer in the comments compared to those which you select for the videos? Thanks for the tremendous effort that you put in. Good question. So when it comes to the actual comments, I try to just get involved in as many of the questions as I can. And in fact, I'm going to go into more detail about how I do that in a second, later on in the show. But we'll talk about how I pick the questions for these shows. And that is, I'm looking for people who I haven't answered their questions before, and as best I can remember. I'm looking for questions that are short and punchy. I'm not looking, because I don't want to read out a big long essay. I'm looking for things that are questions and not necessarily a story, although I do like to sometimes engage if people have a comment and I want to sort of answer that as a comment. So that's sort of the main criteria that I'm looking for when I'm looking for questions that I'm going to be talking about here in the show. Stuff that I haven't answered before, ideally, although, you know, I've answered so many questions now that it's all starting to blur in my head. So there you go. Israel Palanayiki. Hey Fraser, I've heard you mention books in passing before. Do you have a list of sci-fi books you recommend, like 70s by Neil Stephenson or Eon by Greg Bear, big old sci-fi novels with or without aliens? Thanks. I don't, but that's a really good question. That's a really good idea. So I'm gonna do that. If someone can recommend, my default right now is I think I will go and spend some time in Goodreads and just sort of build up this big list of books. But if someone can think of a better place or a better way that I can maintain a list of all of the books that I've read and the books that I'd like to read and the books that I'm reading, then I will totally do that. I would, if you're looking for something recent, an older series is of course the Foundation series, which are just amazing and definitely some of my favorite books ever. Something that's a little more recent, I highly recommend Fire Upon the Deep. Man, and 70s, which you just mentioned, which is one of my favorites, fairly recent.
The Expanse series. Hmm?
Carla likes the Expanse series. I haven't actually read them yet. We Are Legion, We Are Bob was great, the Bobiverse books. So there's a lot of good books, and I should totally do that. I love, some people have been doing things where they'll do like a book review or like a book club. I know Isaac Arthur is kind of doing that. It'd be kind of fun to maintain, like, let's all read one book every month or so and talk about it. So if anyone has any ideas, I'm all ears. Scott Washburn. Why couldn't we use lasers to push the orbiting debris out of Earth's orbit? In fact, lasers are probably the best idea that's been proposed so far to get rid of space debris in low Earth orbit. And in fact, some Chinese scientists just put together a study, and we reported on it on Universe Today, that they would put a satellite up and it would orbit around and it would have like a high-powered laser system, and as it got close to pieces of debris, it would zap the debris, and that would cause a sort of a tiny little bit of gas, it would vaporize a chunk of the piece of debris, and that would give it a new thrust that would then cause it to deorbit. And the problem with all of these ideas about trying to clear up space debris is that each piece of debris has its own orbit. So the only way that you're going to be able to catch it and bring it back down to Earth is that you have to match its trajectory, and that's a very expensive thing to do using propellant. So if you could have this satellite, this killer satellite with all these lasers on board, and they are zapping at various chunks of space debris, it doesn't matter how fast they're moving, because you hit them and then they either burn up or they get a change in their velocity and they get closer to the Earth's atmosphere and then they burn up. So lasers are probably going to be the way that this is going to get done. It's the best idea that I've seen so far. Seth McKay. Hey Fraser, your production schedule looks to be quite full with Universe Today, Guide to Space, QA, Astronomy Cast, not to mention spending time with the family. How do you organize and stay on schedule? It seems like you would have to be really organized to stay on schedule, as well as not end up working all day. I have also tried several hats and need to organize better. I don't know if I've solved the not working all day part. I definitely work a lot of the day, and you're absolutely right. I am very disorganized by nature, and so I've had to build a lot of organizational structures to help me stay on top of everything that I want to do. But there's a couple of tools that I really love. The first one is this idea of the Pomodoro, where you start a timer and you run it for 25 minutes and then you take a break for 5 minutes. And that idea of, like, here's the thing that I don't want to do. Let's say there's a really tricky script that I'm trying to write and I just don't want to do it. I just start the timer and then I just spend half an hour just grinding away, trying to get as much progress as I can. And sometimes I find within 5 minutes, I get through that roadblock and then I'm able to keep writing. So the Pomodoro is great to just kind of commit to doing the work before and not listen to how much you feel or don't want to feel like doing it. And then the other thing that works really well for me is to think about the inputs and not about the outputs. So I will commit a certain amount of time every day to do something that's important to me, like writing or like answering comments on the YouTube. And I will just set the timer again. I'll say, okay, you get half an hour, go as hard as you can, write, get back to as many people as I can, and then go on to writing the scripts or the other things that are important in my day as well. And I find that's very effective for the way my brain works. So if you've got a bunch of projects that you're working on, just be really clear, set a timer, start the timer, work on that project, put in a half an hour or an hour, whatever, and it's amazing what you can build up over time, day after day after day that you work on it. Good luck. Let me know what works for you. Stefan Otley Thorvaldson. How can I become an astronaut if I'm not from a big country like USA, Russia, or the EU? Great question. And to answer this, I'm going to call in a friend of mine, Abby Harrison. She is known as Astronaut Abby, and for the last 7 years, she has spent her entire life learning to become an astronaut from age 13. She's 20 now. She's founded this great group called the Mars Generation and does great blogging and podcasting and videos. And if anybody knows how to become an astronaut, it's Abby.
My advice to you is honestly the same advice that I give students who do live in the US, which is to work hard in school and to be the best in your field of study. You have to be the top of the top. You have to make yourself invaluable because you want to have space agencies want you, basically. The options after that, once you have succeeded in being the top of the top, is that you can apply to another country that does have a space program to become a naturalized citizen. And at least I know that in the US, citizens, doesn't matter if you were born here or if you immigrated here, you can still become an astronaut. Alternatively, you can stay in your country and who knows, in 10 or 15 or 20 years, maybe private industry space exploration will be looking for astronauts from around the world and nationality won't matter as much. So there's a couple of options that you can decide based on your circumstances.
All right, thanks Abby, that's good advice. All right, another question show is over. Thanks to everyone who asked their questions, I really appreciate it. If you've got a question, just go ahead, wherever you are on my channel, on any video, just type it in, I'll gather them all up and I'll answer them here. Another reminder, check out my weekly email newsletter. Go to universetoday.com/newsletter, sign up once a week, tons of space news written by me. All right, we'll see you next week.